Hello friends, welcome back to my Pandal Hub channel. So today we are going to look into some more Java interview questions, basically the interview questions on collections, which is a part 2. Maybe you can check my the previous part for a few more collection questions and let's get into it. So when to use array list and linked list? Array list provides constant time for search operations, so it is better to use array list if searching is more frequent operation than add and remove operation. The linked list provides constant time for add and remove operations, so it is better to use linked list for manipulation. So in the case of array list, if you're going to go in for the searching of elements, so in that case, accessing or searching is very fast in array list as it implements the random access interface. Whereas in the linked list, if you're going to add or remove or delete the elements, that is, if you're going to do some manipulation operations in the list, it is very easy and faster in linked list, because in the case of linked list, along with the value, we have some reference to the next element being stored. That is, we inside the linked list, we have all the elements in the form of a node where it includes a value and a reference to the next element. So in the case, since it has the reference to the next element or a next value, it is easy for us to add or remove the elements in the linked list. So what is the difference between poll and remove method of queue interface? So we know what the queue is. It is first in, first out. So both poll and remove method from queue is used to remove the object and returns the head of the queue. So both the poll and remove methods are used to remove the object, or it is used to remove the object from the queue. So if that is the head element, that is the first element which needs to be removed, the first element which was inserted and which is ready to remove. So that element, both the poll and remove method are going to return. If queue is empty, then a call to remove method will throw exception, while a call to poll method returns null. So in the case if you have a queue that is an empty queue with no elements, and when you're going to use the remove method, it will throw an exception, whereas poll method is going to return null without throwing an exception for you. So by the way, exactly which element is removed from the queue depends upon the queue's ordering policy and varies between different implementations. For example, priority queue keeps the lowest element as per comparator or comparable at the head position. So this head position of a queue is nothing but, the queue is nothing but the first in, first out, as I already mentioned. So the elements that are inserted first will be removed first. So there is a pointer pointing to the uh, first inserted element. That is the latest element, the first element to be removed. So that is called the head. The head represents that will be the next eligible element to be removed from the queue. So for removing, you can use either poll or remove. But in the case if you have no elements in the queue, this remove is going to throw an exception, whereas poll doesn't. So what is blocking queue in Java? Queue is an ordered list of objects where insertions take place at the rear end of the list, and deletion of elements takes place from the front end. That is, which is also called FIFO. I said right. So at one end we are going to place the elements, and from the other end they're going to be removed. The order in which they are placed, they'll be removed. So blocking queue waits for the queue to become non-empty when we are trying to retrieve an element, and waits for the space to be empty when an element is to be inserted in the queue. So you have a queue of particular size. So in that case, if you're going to insert an element into a queue, if the queue is full, then in the case of blocking queue, what it will do is it will wait until there is a space for the element to be inserted. And when the queue is empty and you are trying to retrieve an element, so in that case, the queue, instead of throwing an exception, what it will do is it will wait until an element is available. So all the implementations related to the blocking queue are thread safe. All the methods achieve their events using internal locks or other forms of concurrency control. So inside the blocking queue, so what are all the implementations in sense pushing the elements, popping the elements, inserting, removing, so all those things. So all the operations that are performed on the blocking queue are synchronized and are thread safe internally. A blocking queue does not accept null elements and throws a null pointer exception. So here the case is the blocking queue does not accept any null values. So Java 5 provides a blocking queue implementations in Java, which is available in the concurrent package. So how does a hash map work? So let's just look into the working of the hash map. So the hash map contains an array of node, and node represents a class having the following object. So hash map is nothing but it is represented by array of nodes. So what does each and every node contain? So the node contains a hash integer value, and it contains a key, and it contains a value and it contains a node object. That is, this node represents to a reference to the next value. That is the next node. So the buckets. So what are buckets? HashMap has array of buckets used to store nodes. So HashMap includes buckets. It includes an array of buckets. So in each bucket, there are nodes being stored. A set of nodes being stored. So each bucket includes one or more nodes. So each bucket has an index and contains one or more nodes. If there are more than one node in a bucket, they are stored in a linked list format. So, so the hash map is going to have a set of buckets, and these buckets are identified using an index, and each bucket has a set of nodes. So if you have, that is, each bucket can have more than one or more node. That is, it can have one or more nodes. So if you have more nodes, more than one, in that case, those nodes are interlinked with the reference. That is, each node is going to have the next node reference. So what is hash code method? This hash code method is used to get the hash code of an object. So hash code method of the object class returns the memory reference of an object in an integer form. So hash code is used to calculate the bucket index. Two or more nodes having the same hash code generating the same bucket index as are stored in a same bucket. So in that case, a linked list structure is used to connect the nodes. So this hash code, what it does is, there is a hash code method available in an object class that returns a hash code for an object. So if you want to insert an object into a hash map, what it will do is it will first generate the hash code of that object, and based on the hash code, we are going to identify into which bucket of the hash map that object fits in. So this hash code is used to identify the bucket index, into which bucket index this object can be placed. So based on that, the object is placed inside that bucket. If bucket is, if two objects, for example, if two objects have the same bucket value, they come to a same bucket value, in that case, the two objects are placed in two nodes of the same bucket. So one node is placed adjacent to the other. So first node will have a reference to the next node. So it is stored in a linked list format. So what is equals method? This method is used to check whether two objects are equal or not. So used to compare the key to whether they are equal or not. If the equals method return true, they are equal, otherwise not equal. So this hash code, as I already mentioned, is used to identify the bucket. So if the bucket includes more than one node, so in that case, each node is going to have different values. So if you have stored two values in it, that is, so let me explain you it with an example. So basically, this hash code is used to identify a bucket, whereas equals method is used to identify the value. So how it is used to identify the value? It is used to identify the value during retrieval. So once you insert the values, you need those values to be retrieved from hash map. So during retrieval of the values, equals method will help us to get the correct value. So let me explain you with an example. So for example, you have a hash map here. So you have the buckets from 1 to 10. So each bucket has an index. So now let me check that I am putting so I'm putting a value called 30 with a key fire. So this is going to have a hash map. So this value, this object gets a hash code value calculated using the object class hash code method, and based on the hash code, it is using the hash code, it is going to identify the bucket. Let's assume that the hash code is 115 and the bucket it identified is 3. So here the hash code is 115 and the bucket is 3 and the key is fire and the value is 30. So the next node. So next node for now it is null. Okay. So now I'm trying to insert the other value. So now it is the key is amuse and the value is 25. So based on the hash code, which is 150, it comes to a conclusion to get into a sixth bucket. So here the hash code is 150 and the key is amuse, value is 25, and the next node initially it will be null. So initially it will be null. But when I try to insert the third value called the key games and 40, which is going to have the same hash code, so it turns into the same bucket. So when it turns into the same bucket, we already have one node in it. So what happens is it gets appended to the first node as a linked list, and the next node reference of the previous node is pointing to the next node. And here the next node, we don't have any other next node, so it points to null. So if there are nodes which have common hash code, or if there are nodes which come into a similar buckets, they form a linked list format. So now here, this hash code is used to identify the bucket. So, so where does this equals method help us? So for example, let's consider that you want to retrieve the key games. So during retrieval, what it will do is based on the hash code, it will identify the bucket. So now we are into the six, but in the six, we have lot of nodes in a linked list format. So what it will do is it will check each and every node and uses the equals method to compare the value. So here what we need is the value is 40. So it will go to the first node and uses the equals method to check the value. So we need 40, but it is 25 here. So again, it goes on to the other node to check it. Now the equals method returns equal, because the 40 is the one which we are looking for. So this is the node which we are looking for, and it retrieves for us. So basically, this hash code and equals. The hash code method is basically used to identify the correct bucket in the hash map, whereas equals method is used to retrieve the correct value from the hash map. So what is hash collision and hash table? So two different keys with the same hash value are known as hash collision. So if you have objects with same hash value, then it represents there is a hash collision. So two separate entries will be kept in a single hash bucket to avoid the collision. So as I already mentioned, if two objects are going to have the same hash value, then they are placed inside the same bucket in a linked list format. So there are two ways to avoid hash collision. That is, I said I showed you this in a linked list format. But there is one more way. Like there are two ways basically, that is separate chaining and open addressing. So separate chaining is nothing but that is the one which we followed. Okay. So it is like the linked list format that we followed. So here is a pictorial representation of it, for example. So initially it is an empty table and we are trying to insert 50, and based on the hash code it gets uh, uh, added into first bucket, and again we are inserting 776, it gets inserted into zeroth bucket and sixth bucket, and insert 85. 85 we are trying to insert it, and it is going to get the same hash code as one, and there occurs a collision. So this is called the collision because 85 is also getting the same bucket index as the 50. So in that case, what happens is it just gets added as a linked list as the next node to 50. And again, when 92 is being inserted, again there is a collision, so it gets added or appended to the 85. And here 50 points, the next node reference of 50 points to 85, and the next node reference of 85 points to 92. So there is similarly basic concept of the linked list. And here they are trying to insert 73 and 101, and 101 is going to go into the third bucket where we already have 73, and it is going to add as a linked list here. So this is called a separate chaining, where if you happen to face a hash collision, there is a linked list being created with the reference nodes, next nodes being updated for the previous nodes. So coming to open addressing is like if you have an empty table and you are trying to insert a value and you're going to get a collision. So in the case of collision, what happens is instead of just appending using a linked list to the existing bucket, it will just immediately uh, add the values to the next free slot. So for example, here you are trying to insert 85. So collision occurs. So for 85, what happens is here we have appended the 85 as the next node to 50. Whereas in the case of here, what happens is the next free node other than 1 is the 2. The next immediate free node is 2. So what it's doing is it's just inserting the 85 into the next available free node. And similarly for 92, it inserts in the next available bucket. And similarly, the 73 and 101, they just get filled in the next available free buckets. So this is called open addressing. But the advantage of separate chaining is you you have lot of, that is, you try to use this hash map very efficiently, because since if they are under the same bucket, you are just creating a linked list, and you can just keep on increasing the size of the hash map without any issues. Whereas here, when there are it's very easy for all the buckets to be filled, because when you're trying to insert an object or a value of a same hash code or a same hash value, in that case, there happens to be a collision, and it immediately moves on to the next free bucket. So this way, what happens is the buckets will be easily and fastly filled, and the hash map turns to full very easily. And each and every bucket is used only for a single element, and it is not used efficiently. How is hash set implemented in Java, and how does it use hashing? So let's see the below example of the syntax of how hash set is being declared. So set is equal to new hash set. So here I'm adding two elements to the hash set. So hash set is nothing but it is a set where we don't have duplicate elements. So hash set internally uses hash map. So hash map instance, so the only thing, the difference between the hash map and other things is when you go for a hash map, you have a key value pair, and you have the hashing techniques, and you have the hash code and equals method, and as we just now discussed, we have the hash code method to identify the bucket, and we have all those linked list concepts and all those things. But in the case of hash set, but it internally uses a hash map, but we don't use any key value concept here. We are just adding only one element to a hash set, and it is working fine. How does it work? See, hash set is built on top of hash map. For hashing, we need both key and value. Key is used to identify the correct bucket in hashing. But here in above example, we don't mention any key while adding elements to hash set. Instead, we give only values. So here in a hash set, which it internally uses hash map, but still we enter only values and we don't enter keys. So how does that work? So internally, when we look into the source code of hash set class, it uses a hash map with keys as user given values and the same dummy object as value for all the keys as below. So when you look into the internal source code of hash set, what it happens is it is just creating a dummy object like object present. So when we invoke a add method of hash set, it puts entry in hash map as below. So whenever we just give set dot add of 1, okay. So what it does is it is adding. So we are giving set dot add of object. So internally the hash set has this add method. So inside the add, what it does is, so inside the map, it just puts the user given value as a key followed by the dummy object, the present, which it has inside this class as a value. So here in our example, we are just adding two objects, 1 and 2. So how does that internally work is map dot put of 1 comma present and map dot put of 2 comma present according to this code. So here what happens is all the keys are unique, so that we have maintained the set structure where the set says we have only unique elements and not duplicate, and the values the values are going to be the same, which is the present, which is a dummy value, just to associate with the object in the backing map. Since keys are unique in a hash map, it provides uniqueness guarantee of a set interface. So we already know that in a hash map, all the keys should be unique except for one null value which we can use as a key. So by default, since the keys are unique, the hash set values are going to be unique and it will not allow any duplicates. Even if we try to insert, it gets overridden. How can we use a custom object as a key in collection classes like map or set? So custom object, what is a custom object? For example, you have an employee class and you want to use that employee class object as a key to a hash map or a set or any other collection class. So in that case, you need to override equals and hash code method inside the employee class. So you have to make sure that the hash code and equals method are appropriate. That is, if you have a weak hash code or equals method, there is a problem of performance, like the same value can be overridden, or you may end up in a case where you may enter duplicate values into the hash map. And equals method should also be appropriate because it is the only one which helps us to retrieve the value from the hash map properly. On the other hand, if we are storing a custom object in sorted collection, example sorted set or sorted map, we also need to make sure that our equals method is consistent to compare to method. Otherwise, that collection will not follow their contracts. Example, set may allow duplicates. So, for example, as I already mentioned, we need to be so consistent or so efficient in writing the hash code and equals method. If not, then we may end up in duplicate values in the hash map, or we may end up in improper utilization of the hash map, inefficient way of using the hash map. What is navigable map and its benefits? Navigable map was added in Java 1.6 and it adds navigation capability to map data structure. So it provides methods like lower key to get keys which are less than specified keys, floor key to return keys which are less than or equal to specified keys, or ceiling key to get keys which are greater than or equal to specified key, and higher key. So these are some utility methods which the navigable map provides in addition to map data structure. It also provides utility methods to create submap. That is, if you have a map, you can just create a subset of it using these methods. For example, like head map. This method returns a navigable map whose keys are less than specified, and tail map whose keys are greater than, and similarly a submap if you give a from and to range, so that the map will be subsetted from that range with whatever is specified by the user. When does concurrent modification exception occur in iteration? As per iterator's contract, if it detects any structural change in collection, example adding or removing the element once the iterator begins, it can throw concurrent modification exception. While iterating, when we try to remove the object using collections or lists, remove method, example remove or remove of integer. So instead of iterator's remove method, then concurrent modification occurs. So what does this say is, so you have two types. I mean, you have two modes where you can iterate through the collection. So for example, when you are iterating the collection and you have some logic to remove or exclude the elements based on the condition of that logic. So yeah, and when you try to remove the elements from it during iteration, so in that case there are chances where you can get into concurrent modification exception. So if you have a scenario to remove the elements while iterating, then what you should do is you should use iterator's remove method. So we have remove methods in collection interface also. Like you have collections remove method which takes object as an argument, and you have list remove method which takes index as an argument. So when you try to use the remove methods of the collection or the list interface, in that case you're going to get the concurrent modification exception. But when you try to modify the collection during iteration using the iterator's remove method, then this exception doesn't occur. So what is the difference between synchronized hash map and concurrent hash map? So concurrent hash map. Concurrent hash map is a class that implements the concurrent map and serializable interface. So we can synchronize the hash map by using the synchronized map method of the Java util collection class. So this concurrent hash map by itself is a separate hash map which is available for us, which provides thread safety. Whereas synchronized hash map is the one which we can explicitly create using the synchronized map method. That is, you are converting a normal hash map into a synchronized hash map using this method, so that it gives us thread safety. It locks some portion of the map. It locks the whole map. So what does this say is, in concurrent hash map, instead of locking the whole map, only a part of it is locked. Whereas in the case of synchronized hash map, the whole map is locked. Concurrent hash map allows performing concurrent read and write operations. Hence, performance is relatively better than the synchronized map. So what does concurrent hash map allow is? It allows concurrent read and write operations. Whereas in the synchronized hash map, multiple threads cannot access the map concurrently. So in the synchronized map, only one thread can access the map at a time, whereas in concurrent hash maps, multiple threads can access the map at a single time. They can read and write the hash map. So concurrent hash map doesn't allow inserting null as a key or a value, whereas synchronized hash map allows inserting null as a key. Concurrent hash map does not throw concurrent modification exceptions. Synchronized hash map throws concurrent modification exceptions. Since concurrent hash map just works on a copy of it, it doesn't throw concurrent modification exception. Whereas synchronized hash map works on the original map, and the original map, the complete map is being locked by a thread. So in that case, it throws concurrent modification exception. So what is this concurrent hash map? I said it just locks a small portion of the map. So what is that small portion? So the difference between the hash map and concurrent hash map is you have a hash map here. This represents the hash map. Whereas in the concurrent hash map basically includes a different segments, and each segment is going to have an index. So every segment has a copy of the complete hash map. So whenever the concurrent hash map is used by the threads, they acquire a lock over a segment and then they read or write on that map. So multiple threads can access different segments at a single time. Only during a write operation, it is going to acquire a lock and then write it in the hash map. Whereas in the case of a hash map, the hash map is being directly completely locked and only one thread can access the hash maps individually. But in the case of concurrent hash map, we are just locking the segments, not the hash map. So each segment has a different copy of it, so multiple threads can access it. So here is the difference between the hash map, hash table, synchronized hash map, and concurrent hash map. So here the hash map is not locked. So two threads can parallelly access it, but you don't have a thread safety here. So it's not thread safe. It accepts one null key and multiple null values in a hash map. So going to hash table, it is synchronized internally. You don't need to explicitly convert it to a synchronized map because hash table is internally synchronized, so it is thread safe. So when one thread is accessing the hash table, the other thread has to wait until the thread one releases its lock. So the performance is slow since it is synchronized and has a lock mechanism inside. The performance is little slow. So it doesn't have any null keys or values which are allowed into the hash table. So coming to synchronized hash map. So here, even in the synchronized hash map, the whole hash map is locked. So when thread 1 is accessing it, the thread 2 has to wait until the thread 1 releases its lock, and it is thread safe as expected since it is synchronized, the performance is slow, and it accepts null keys and multiple null values. And going on with the concurrent hash map, here instead of locking the whole hash map, we have segments. So each segment is locked based on the thread it is going to access. So thread 1 is accessing the first segment, and thread 2 is accessing the third segment. So for a single segment, multiple threads can access it for a read operation. But whereas for a write operation, where the thread 3 is waiting on the same segment, so for write operation, one thread has to wait for the other to release the lock. Whereas for read operation, multiple threads can access the single segment for a read operation. So it is thread safe, fast performance because we have multiple copies of the hash map in each and every segment, and multiple threads can access it at a single time for multiple read and write operations. No null keys or values allowed here. Thank you folks. Thank you so much for watching this video. Hope this was helpful for you. Please like, share and subscribe, and please let me know if you have any comments, and please do watch my other parts for additional questions, and please do let me know if you have any comments. Thank you.